Time this morning. Let's see what Ironbrew can do for you. Up in the bars, Ironbrew and the skies. Sarah's here.
Hi there. Portland's Road and Cowcaddens Road are both busier than usual, but other city centre routes are running smoothly.
Everyone comes across the bridge if they're going to the airport, if they're moving transport around. And with today's just-in-time delivery mechanisms, people need to rely on the delivery times. It affects the business community, it affects transport, it affects leisure, because people need to get around Glasgow quickly and around the west of Scotland quickly.
More traffic crosses this 10-lane bridge than any other in the UK, over 155,000 vehicles a day. Strategically, Kingston Bridge is the nucleus of the west of Scotland's motorway system. When opened in 1970, it was well understood what the volume of traffic would be more than 20 years on. What was never predicted was the volume of newsprint. A private report had been leaked to the press before the project team had seen it. As a result, the tabloids and technical press homed in on the story, devoting huge spaces to sensationalist headlines and pictures. The reality was that technical assessments had identified major defects in the structure. Like any bridge of its type, Kingston Bridge's design allows for movements in the structure. However, in this case, the reality had become very different from the prediction. At the centre of the span, a dip had appeared in the bridge's deck. Underneath, stress cracks had developed in the panels. In this type of construction, the centre and end spans are held under compression by pre-stressing. Cracks underneath the bridge, in other words, a relaxing of this built-in stress, signal a potential weakness in the centre span. On the north bank of the river, cracks were apparent in the quay wall, while alongside, timber piles were bulging. On the road surface, expansion joints designed to open and close with changing temperatures were raising other questions. Why, on the south of the bridge, was the comb wide open, while the north joint remained closed completely? Here, at the north support pier, this cutwater facing unit had quite clearly moved out of alignment. It should have looked like this. It now looked like this. And at the base of the same column, its outer concrete skin was crushing. Put simply, the deck of Kingston Bridge had moved northwards, effectively leaning on and pushing the north approach structures. Adding to the sum of all these defects, the facing material on the bridge parapet was also crumbling. From the outset, it was clear that the management philosophy of the project team, developing the concept of the intelligent client, was going to establish a new working principle for a major roads authority. Normally, an authority either carries out work itself or employs a consultant. In the case of Kingston Bridge, a project team was set up, headed by a project manager. It includes selected companies, consultants and a private advisor. People who have the right expertise and, because the chemistry is right, can work well together. The team operates as a cohesive and effective group rather than as individual companies. Monitoring the bridge has been key to the entire project. Over several years, the team has recorded and plotted the fractional movements between each of the structure's components, along with other data, building a detailed picture of how the bridge is acting in reality rather than as designed. 36 sensors on the pillars and on the ground feed information on the bridge's local movements to computer every 15 seconds. 16 reflecting prisms are fixed to the bridge. Every month, they track its global movements, measured by land surveying techniques. 128 thermometers set into the bridge measure the bridge deck temperatures. Air temperature, wind speed and direction, plus relative humidity and solar radiation are also recorded. Kingston Bridge is probably the most heavily monitored bridge in the world.
What we have here is a plot of the global movements of the bridge plotted against temperature. And what we need to look at is the fact that the green squares shouldn't be moving at all. If the bridge is behaving as it should be, that should be a horizontal line. So this is the first alert that we've got something odd going on.
Professor Alan McGowan of the University of Strathclyde is advisor on the monitoring system.
These are very accurate instruments, going down to something like 1/10 of a millimetre in accuracy, recording every 15 seconds. In this area here, we're measuring the vertical movements so that this gives us the tilt of the bridge.
The bridge is now monitored 365 days a year, ensuring that it's safe, and equally importantly, to check that it stays safe during construction work. The first strengthening contract was for the stabilisation of the quay walls. The lean of the north piers meant that there was a horizontal load applied at the foundation level, pushing them towards the river. If the quay wall had collapsed, rapid washout of the sands and gravels below the footing was a real possibility. Around the pillars, the ground was found to be particularly suitable for jet grouting, a technique by which a drilling and mixing process creates a succession of interlocking concrete underground columns. This was combined with a programme of rock fill in the river itself. The plan ensured the pillars and quay wall remained stable at every stage, and at no time was bridge traffic disrupted. Work also began on refurbishing the bridge's cope and parapets. This hydro-demolition technique removes the deck concrete, while leaving the reinforcement undamaged. A new steel cage is then connected to the exposed reinforcement, and a new concrete edge cast round it. But serious though these problems were, they were only part of the story. Further assessments had to be carried out on the bridge, since, like all similar long-span bridges, it now required to conform to new European legislation on loading. More remedial work was needed to strengthen the superstructure. The problem was this. Assessments had shown that in extreme cases, too much load on the centre of the bridge could cause the ends to lift. Because it was realised the strengthening work would take some time, interim measures were imperative. Immediately, one lane of the bridge was closed to vehicles of over 7.5 tonnes. One lane was closed completely, and concrete ballast was positioned on the deck extremities. As a second stage of interim measures, beams were connected to the deck. A collar was cast and stressed onto the columns of the approach structures, and the beams were connected to the collar through bearings. Increasingly, the engineering techniques and monitoring system have attracted professional interest from all over the world, and many delegations have visited Scotland to see progress firsthand. There have been visitors from Europe, America and China, and technical lectures have been given in the United States, Canada and even the Far East. The ongoing bridge strengthening programme has created even more challenges, taking on the task of fundamentally changing the bridge's system of articulation. The plan to replace the system of bearings on the north and south piers was this. First, construct strengthened piers. In essence, this requires new piers to be built surrounding the existing ones. At this point, a jacking system supports the bridge and the new piers, after which the old piers are removed. Finally, jack the bridge deck to the south, install new bearings and remove the jacks. In appearance, it's a transformation from this to this. The last stage of this strengthening contract will be post-tensioning of the centre and side spans. Multi-strand tendons stretching through the bridge's internal cells will be anchored at various levels in each of the side spans to induce compression in the deck. Even after this contract has been completed, further work will still be required to bring the bridge up to current day standards. Future contracts will replace the expansion joint bearings, replace further stretches of the parapet and waterproof the bridge deck. Kingston Bridge has been described as the heart of the West of Scotland road system. What has to happen now is major surgery.
It begins in the autumn. This will be the first stage of lifting the bridge deck, which by any measure is a complex manoeuvre. The prime objectives will be to ensure the continuing safety of road users and keep to an absolute minimum any interruption to Glasgow's vital traffic flow.
Temporary bridge closures will, of course, be unavoidable, but to limit their effect, a strategy of alternative routing has been developed.
To eliminate large-scale inconvenience for all road users, the bridge's work schedule has been accelerated, bringing forward the time frame to avoid the Scottish Motor Show, the SEC's largest regular event, the Christmas shopping period and the festive holidays. For the first deck lift, Kingston Bridge will be closed for just 3 weekends, each from the Saturday evening through Sunday until 6 a.m. Monday. These days and times will therefore avoid disruption to peak traffic and ensure uninterrupted bridge access to every major West of Scotland event. During the closures, a network of diversion routes will be set up. 5 routes to cross the river from the west, 6 routes from the east. Drivers will be guided to and through the most efficient local routes by a clear and highly visible system of road signs, including the National Motorways electronic NADIX displays. In advance of these activities, there will be a major publicity and information campaign, clarifying dates, times and diversion alternatives for road users. Throughout the campaign, drivers will be encouraged to use park and ride facilities and public transport. Even cycling will be a healthy option for many, all of which will simplify trips into Glasgow.
The work in Kingston Bridge is essential, and the Scottish Office and Glasgow City Council are committed to putting in place a well-coordinated action plan to maintain high levels of safety.
In the long term, today's vital measures will raise the standard of the bridge's infrastructure dramatically, keeping Glasgow ahead as a city and bringing social, economic and environmental benefits to the west of Scotland.